What's up, everybody, and welcome to another Deep Learning with Python, TensorFlow and Keras tutorial series. In this video, we're going to be continuing along on our little mini project of implementing a recurrent neural network to predict the future price movements of a cryptocurrency based on the sequences of that currency's prices and volumes, along with another 3 cryptocurrency prices and volumes. I think I got that right. All right, so let's get into it. So far, we've got the data, we've merged all the data, and we've created targets. Now, the next things that we have to do, we do have to make sequences out of that. We have to balance, normalize, scale, all that fun stuff. But the next thing I want to focus on is out of sample. So before we start, shuffling and doing all these things, we need to immediately separate out our out of sample data. Now, in the case of temporal data and time series data, and really a lot of sequential data, I would argue, you can't just shuffle and then take a random 10%. And the reason why you can't do that is, so our sequences are, 60 minutes long, and we've got 60 units in each sequence, right? And we're predicting out 3 minutes. The problem is, if we were to shuffle this data and then just pick a random 10%, the out of sample samples would all have very, very close examples in sample, and it would be relatively easy for the model to, as it overfits on the in sample data, to also just that overfitting pour over into out of sample. So instead, what you have to do with sequential data in most cases is take a chunk of the sequences and separate them away. Now, in the case of time series data, I would take that a step further and say, really, out of sample needs to be a chunk of data in the future. So in the case of our data, we want to take, let's say, the last 5% of the historical data and separate that out as our out of sample data. So that's what we're going to do next. And I think that's the most realistic way to do out of sample testing, aside from maybe doing like a true forward test, like using all your data and then testing it forward. In this case, this is basically the exact same thing. It's as if we built the model, 5% of time ago, and then forward tested it. So anyways, that's what we're going to do here. So I can't tell you how many times I've seen, finance stuff or even just any sequential stuff, but it's usually with finance that people do, time series data, where either they don't do out of sample and they're like, wow, look how good my model fit. And it's like, whoa, with a big enough neural network and enough epochs, you will absolutely overfit your data to a perfect or almost perfect fit. But they don't do true out of sample, or they screw up on the out of sample doing a method like I just said. So it's really important to keep that in mind. All right, so let's go ahead and say like our last underscore 5% of time. That's going to be equal to, and in fact, let me just do this. Let's first take times. And we're just going to say times is the sorted. They should be in order, but this is really important that they are in order. So we're going to sort them. Sorted, and then main df.index.values. So .index just references the index. .values converts it to a NumPy array. So those are the times. Now what we want to find is, where's the threshold of like the last 5% of times? Like what's the actual Unix time that is the threshold of 5%? So the way that we're going to grab that is we're going to say last 5% is equal to times, and then we want to get the index value. So the index value should be something like, let's say it should be something like negative, I forget how many things we have. It's probably like, let's say if you had 100,000, it would be about the index of negative 5,000, right? Or it would be the index of 95,000, something like that. So the last 5% will be times minus, or the index is a negative, not minus, the int value of 0.05 times the len of really anything. It could be main df, but we'll say times. So that'll give us the threshold. So let's just go ahead and print that out. Last 5%. I'm going to comment out that now, and let's just run that real quick and see what we got. Okay, so we actually have a timestamp now. So now we can actually separate out our validation data or out of sample data and our training data. And we're going to do that now. Before we do anything else, we want to separate that out. That it can kind of create a problem with normalization, stuff like that. I'm not going to worry about that right now in scaling, but not going to worry about that. It's far more important that we get this right than anything else, and we can figure out a better way later. But we definitely want to make sure we get this right. So we're going to say validation underscore main underscore df equals main. Oops. That's main df, where main underscore df dot index is we'll use greater than or equal to last 5%. So that is, so our validation data is basically anywhere where the timestamp is greater than this value. So it should be the last 5%. And then we want to do basically the exact same thing for the actual training data, which will retain the name main.df. And main.df equals main.df, where main.df.index is less than last 5%. So now we split up the data. And the next thing that we'd like to be able to do is now, we need to create our sequences, we need to balance, we need to scale, and probably other things I'm not thinking of right off the top of my head yet. And so what we want to do is make a function to do all those things. But we're going to do all those things on both of these. Or basically, we want to make some code to do all those things. We need to do it on both of these, so we need to make a function. So what we want probably is a function that's going to do something like allow us to do this, like train x, train y equals some sort of function. I'm going to call it preprocess df. And then you just pass a df. So train x, train y will be main df gets passed. And then we'll do the exact same thing for validation x and validation y, and we want to pass the validation main df. So that's like what we're hoping to be able to do. So I'm going to comment those out for now, and now we're just going to go up to the top here, and we are going to start creating our preprocess df function. So define preprocess df. It's going to take in a df as a data frame as a parameter, and I think the first thing that we'll do is the scaling, and to do that we're going to from sklearn import preprocessing. Again, if you don't have this, it's a pip install sklearn. I think it's sklearn. It might be a scikit-learn. I actually don't know what the let's see, let me pull this down. I don't think I need that to be running. Let me do pip install sklearn. Okay, yeah, so pip install sklearn. I didn't know if it was scikit, dash learn or what, 'cause that's what the package is called. Anyways, okay, so we get the pre-processing, and now we'll come back down to this data frame or the function that we're going to build. And first we're going to say df equals df.drop. What we want to drop is that future column. We don't need it. It carries no significance to us anymore. We only needed that column to generate the target, and you definitely wouldn't want to accidentally leave in the future column, because that would be that would allow the network to learn really, really quickly how to predict the future movement. So we want to drop that. The next thing that we're going to go ahead and do is we're going to iterate over the columns, and we want to scale those columns. So what we're going to do is for call in df.columns. What do we want to do? Well, as long as column is not target, because we don't actually target. There we go. We don't actually want to. Why are you all angry at me? We don't need to scale. We don't need to normalize. We don't need to do any of that to target. Target is done. It's a completed column. We don't need to do anything more to it. Now, for the other columns, we do need to do some stuff. One of the things we need to do is, so df call now is going to become df call dot percent change. And the reason why we want to do that is this normalizes all the data. So whether the price, it moved from 10,000 to 10,005, or it moved from, a few pennies to a few more pennies, percent change normalizes that because, Bitcoin is a different price than Litecoin is a different price than Ethereum, and so on. So this helps us to do that. Same thing is true with the volume. The volumes are, different in terms of magnitude, but their actual movements, the trends of their movements are what we're trying to analyze for their relationship to other prices and stuff. So anyways, we normalize everything with a percent change. Then we're going to do a df.dropNA in place equals true. Percent change will definitely spawn at least 1 at the very beginning, but just in case, these things love to creep in and they're going to cause a heck of a lot of trouble for us, so we're going to drop them if they appear. Then we're going to say now df.call is equal to preprocessing.scale. And what do we want to scale? We want to scale df.call.values. So what is this? So preprocessing is from sklearn. There is some preprocessing in scaling with Keras. I have used it. I don't know how it works. In general, I've been relatively unhappy with how it scales the values. For some reason, I don't see it actually perfectly scaling from 0 to 1, which is the target. I am sure there's a way to do it. It's just that this works just as well. So I'm going to use that. Like I said, I'm aware it exists in Keras, and I think the cool thing with Keras is you can, multi-axes data you can scale as well, and I don't think you can do that with scikit-learn. But again, I've not tried. Anyway, many ways to skin a cat. You also could scale it's like the current value divided by min minus max, I think, or something, or whatever that is. There's a really simple formula that you could scale with. So however you want to do it, just scale the data, try to get it to be between 0 and 1. So this is how I'm going to do it for now. If that bothers you, feel free to do it a different way. Okay, so now that we've done that, at the very end, let's df.dropNA again, just in case. So if this creates, an NA, which it definitely does, the percent change, we're going to drop it. And then this here, just in case for whatever reason that creates not a number, we're going to make sure we drop it again. Okay, let's do, I think we got time. We'll stuff in the sequential data as well. So now what we're going to say is sequential data is equal to an empty list. And then we're going to say prev days is equal to, and we're going to use a day queue. Max len, actually it should be one word, max len equals whatever the sequence length is. We need to go ahead and import day queue. So I believe it's from collections, import day queue. Now day queue is a fancy little dude. What it does is, so previous days is a day queue with a maximum length of 60. So it's basically, you can think of it like a list, and as all you do is you just keep appending to this list. But as this list reaches the length of 60, as it gets new items, it just pops out the old items. And so we don't have to write that logic, it just does it for us. So what we want to do is we're going to wait until prev days at least has, 60 values. And then from there, we're just going to keep populating it, and that's going to be our sequence. So now what we're going to do is for I in df.values. So what is df.values going to be? So probably I think what I should do too, let's print df.head just so everybody, df.head, as well as for C in df.columns, print C. I just want to make sure everybody knows, because at this point we're starting to get a little crazy. Preprocess df. We need to at least run. I'm just going to come down here. Hopefully I don't forget to undo this. Main df. I just think hopefully this will help to kind of visualize what's happening here. Do this. So we've got our target. Everything's been converted to percent change as well as been scaled. And then these are all the columns that we're working with, and these are the columns in order. So for input data to measure what the target is, we're going to use all of these, which is Litecoin prices, Ethereum prices, Bitcoin prices, Bitcoin Cash prices, and so on. And then we've got target. So the sequences will be sequences of prices and price and volume for all of those. but it can't contain the target because, again, that would be cheating, right? So what we're going to do is come back up to where we were working. And in fact, I guess I'll leave that for now, but I'm going to delete this stuff. So what we want to do is iterate over the columns. So for I in df.values. So df.values just converts your data frame to a list of lists. So it won't contain time anymore, but it's in the order of the index still. But it is going to contain target, so we need to be careful. So for I is just the row of all the columns. So, Bitcoin close, Bitcoin volume, Ethereum close, Ethereum volume, and so on. So what we want to say is, as we iterate over this data, for I and df values, what we want to say is prev underscore days dot append, and what we want to append is a list, because the sequence is going to be a sequence of lists. What we want there is n for n in I up to -1. What's going on here? N for n is each value in that list of lists, which again, it is each of the columns, right? So the close, the volume, but also includes target. So we're going to say n for n in I up to the last I. So we are not taking target. Hopefully that's as clear as possible. So that gives us previous days. Now, if previous days is equal to the sequence length that we require, so if len prev days equals 60, and actually not 60, but seq lang, whatever that is, it is 60 right now, we're going to say sequential data dot append, and now we're going to append our x's and our y's, so our features and our labels. That's going to be it's going to be a NumPy array of the previous days. So it's that sequence of 60 features, or 60 feature sets, I guess we could call it. So append that, and this needs to be a list. So it's the features, and then the label. So the label is pretty simple. It's just I -1. So that's the current label right now. What's the current label? So based on the last 60 minutes of all that data, we are hoping the model could predict, yes, that label, either a 0 or a 1. Okay, so we build sequential data, and when we're done, we are going to do a random nut shuffle. Sequential data. And we probably don't have random. We do not, so we'll import random. Well, let's run that, see if we hit an error. We do. NumPy not defined. We're going to need that as well. If you don't have NumPy installed, do pip install NumPy. We will try again. This step can take a little bit because you're building sequences, but it's done. Okay. So, I believe we're done. I don't think I'm going to continue until the next video. This one's probably pretty long. Okay, so now we have our sequences. We've got our targets. We are closing in on the ability for us to feed this through a model. We still have a few more things we need to do, but we are getting close. So this one's a little dense, so the other ones have been kind of dense. If you've got questions on whatever's happening here, or if you think there's a better way to do something, please, by all means, let's talk about it in the comment section. Let me know. Otherwise, I will see you guys in the next tutorial where we're hopefully going to get closer. We probably won't train the model in the next one. It'll probably be the tutorial after the next one. But we'll continue trudging along. So anyways, questions, comments, concerns, whatever, feel free to leave them below. Otherwise, I will see you guys in another video.